Hello friends, welcome to my channel. Let's have a look at a daily challenge problem, that is problem 429, N-ary tree level order traversal. So in this video, we're going to share a very routine solution based on level order traversal of trees. So this is actually the same problem as a level order traversal for a binary tree, but the context here is N-ary tree. So first, let's read through the statement of the problem, and then we do a simple analysis and share the code. So given an N-ary tree, return the level order traversal of its node values. So N-ary tree input serialization is represented in their level order traversal. Each group of children is separated by the null value. So here are some examples. So we can have a look at example 1. So in the first level or 0th level, so we have the root itself. So this is the corresponding output. And in the second level or first index level, so we have 3, 2, 4. So this is the corresponding array. And in the third level or second indexed level, so we have 5 and 6. So this is the corresponding array. So similarly, we can check the return for example 2. So here are 1, 2, 3, 4, 5. So there are 5 levels. So the output is an array consisting of 5 arrays. So 1, 2, 3, 1, 2, 3, 4, 5, right? So the constraints and additional assumptions on this problem are the following. First, the height of the N-ary tree is less than or equal to 1000. So the total number of nodes is in between 0 and 10 to the power 4. So these two constraints actually confine or put a boundary on the problem size. So with that said, actually we are ready to do the analysis and write the code. So we are going to use a solution which is parallel for the solution of level order traversal for a binary tree. But the content is that, so here the class definition of node is the following. So we have two fields. One is a value field and the other is a children field. So this is a difference. So with that said, so I guess we are ready to write the code. So first, I'm going to initialize a result variable. So this is the container going to hold the array for each level. And then we're going to first check a condition, if not root. So we're going to return this result. So the reason is that the height of the N-ary tree is less than or equal to 1000. And the total number of nodes is in between 0 and 10 to the power 4. So in other words, so the tree can be null. So in this case, so we check the edge case and return the empty array or list. So next, basically, so we can make some annotation. So this is the edge case. So another case is basically the level order traversal. So here I'm going to use list comprehension just for convenience. So you can check the video for the level order traversal in the context of a binary tree. So now, with that said, I'm going to first make a level to be the root. So in this case, the root is not null because we have treated the edge cases. So then we can actually initialize the while loop. So while level. Then the first thing is that we can get the node values in the current level and append to the result. So what we're going to do is result append. So we're going to use a list comprehension. So node value for node in level. So notice that we are going to make sure that the nodes in each level is not null. All the nodes are not null. So this is the one thing. So next is to update the level. So we're going to reset the level. We're going to use another list comprehension. So we're going to child for node in level. So we're going to check all the children for the node in the level, or in the current state of the level. So another loop is for node in level and for children in node children, for child in node children. So we're going to make a filter. So if child is not null. So this actually is the bulk of the work. So next, after we update the state of the level, we just need to return the result. So that's actually all for this format of solution. So we can first do a special case check. So node has no attribute children, so I'm going to change this to the correct spelling, so children. So let's run it again. So yeah, it passes the first example. So now let's do a generic case check. Yeah, it passes all the generic case. So this problem actually is very routine. So the Leetcode marked it as media. So if we have practiced the level order traversal for a binary tree, so this problem should be routine. So it contains essentially just two operations. One is add the node values to the output and then update the levels. So with that said, I guess that's about it for this problem and this video. Thank you very much.